case. All right, so we're working on our W2. We're working on the activities for this week. And I made my little thing. So this is going to be fprintf, and this is tutorial 1. Tutorial 1, fprintf, and this is by Bill Loring. Oh, good enough. This is for later on. All right. So, hi. So we've done variables before, and there's two different, you'll notice that I don't know. There's MATLAB, as far as I can tell so far, really doesn't have a convention on what sort of naming to use. How to name things. So you may see some programs where I do this. And you may see some programs where I do this. That's called snake case, and that's what you use in Python. This is called camel or Hungarian notate or camel case. You capitalize everything after the nose of the camel. So either one is fine. Stick with one and don't do what I'm doing, which is I forget and I go between one and the other. So we're going to create a string variable named Bob. Oh, I just saw what is that show that has the blob named Bob? It's an animation. Anyway, it doesn't matter. Monsters Incorporated. I just saw one of those. All right. So we have our string. We have an integer. And we'll do a lot of combining strings, text, and numbers. So fprintf is a function that allows us to format our printing, hence the F part. So if I'm doing numbers, I have to put in, if I'm doing a string, so when you're printing, you always are sending out a string. Let me back up. There's 3 parts to a program. The first part is input, second part is
variable.
Calculate. Yep, and the third part is output. Yes. So when we're outputting something from a program, right now this is a number. Well, we can't send numbers to the console. We can't output numbers. It has to be converted to a string. So that's why we have a double quote here. When we do percent inside of a double quote, we are saying that we want to substitute a variable for that. And when we do %s, that means we are doing inside the double quotes like this. This means we are wanting a string variable to be put in that place. How does MATLAB know which string variable to put in? It's the first one in our variable list. So if I run this, which I will, I'll end up with Bob printed here. So this part after the comma is the list of variables that will be printed in this string, because everything coming out of a program has to be a string or text. And if I run this guy, I'm running the whole thing. Now it's probably a mistake. Let's just run that section. I'm still running everything. All right, just a minute here. There's my section break. Let's try that again. There's Bob. So the % means I'm substituting a variable when it's inside a string. The % means I'm substituting a variable from over here, and I want the value displayed. Each variable contains a value. In this case, the value of first name is Bob. Well, I want to put in my integer too, and it's going to be the second one in there. So I would type in, put a comma, and I put in age. Well, until I tell MATLAB where to put it, it's not going to like this. I do with integers and other numbers. I put in the % to start. Now I want to format this because this is considered, even though I typed in an integer, by default, everything in MATLAB is considered a float, and we'll get to the whole changing things later on. So I do %f, That'll allow me to display the age. F for float. Float is how computers compute and do decimal numbers. Floating point. Well, I also want to display a certain amount of decimal points. So if I do .0, I'm going to get no decimals. Let's try that without that once and see what it looks like. There. MATLAB, in its wisdom, added all those zeros after there. Well, Bob. Oh, there we go. As you're working on a program and you don't want to have to clear the command window all the time, if you put CLC in there, that clears the command window each time you run it. That's an optional thing that you can do. I do that when I'm working on it, so I don't have to keep clearing it and figure out which thing I just ran. CLC is not intuitive that it clears the command window, but that is what clears it. So let's try that again. Bob is, 45.000000. We don't usually say to someone, oh, I'm 45.79 years old. We usually say, I'm 69. So to do that, we put that in. 0.0 means we want no decimal places. If I wanted 2 decimal places, I put 0.2. I want 0 because I want Bob to just be 45 years old. So I run it. Now Bob is 45. And all of this is notated in the tutorial. You don't have to memorize this stuff. But it wouldn't be a bad idea to put a few notes about this because we're going to be using this for on and on and on. Now, this is one way to do this. We pretend that it's a float, but it actually is an integer. So the integers are done if you know it's an integer. That's intuitive, isn't it? D for integer? The answer would be no, that's not intuitive. Why can't they use I for integer? But no, they use D when it's expecting a integer. There. Now, if I type in 0.236, Bob is 5.236. Not exactly what we're looking for, is it? I'm formatting it as the wrong type. So MATLAB tried to weirdly convert this into an integer and it didn't work. There, does that look better? So we want to pay attention to what computers treat integers different when they treat decimals. Whole numbers and decimals are treated differently. And we can tell MATLAB, specifically, I want it like this. We can also just display it differently. Now I get Bob's age with 2 decimal places. So far, so good?
What are string variables?
What are what?
String variables? You said the S stands for string variables?
Right. So Bob, this is a string. Anytime we have double quotes around something, it's a string. So if I had this number and I put double quotes around it, I can't multiply with it because it's a string. But I could do that if I wanted to just display that information. If you have a number in a program, now we can calculate with that number. A number is a number. Anything between double quotes is a string or text. All right. So what if we print more than one thing? Well, let's do fprintf. And we'll just print EOL, which means end of line. That's a old computer thing, which computers used to print out saying end of line, that's the end of the program. You can put anything in there you want, but watch what happens when I run it. If we do a display, everything gets its own little line. That does not look good, does it? Because I wanted EOL on the second line, because that's the end of my program. We have to add something in here called an escape character. Slash, the left slash, is called an escape character. When it's used in a string, it's telling MATLAB to take a different interpretation of whatever I'm typing in. So if I type in /n, that means I want a new line after my fprint statement goes. So fprint does not automatically go to the next line. We have to tell it. If I just had an n in here, MATLAB would print an n. But this is called an escape code. It tells MATLAB that this has a special meaning, and its special meaning is kick down to the next line. Now I run it. It looks beauteous. And this is always placed at the end of the string part of fprintf. We could also put it here, but we really don't need to because that's the end of my program. All right, so. Oh. Apparently. If we use, let's see. %f, and I thought pi was a built-in. It is, okay. So in a programming language, it'll have built-in what are called constants, meaning you don't have to put in the value for pi. Whoops, wrong place. Let me move EOL over. So if you need to work with pi, it's just pi. You get pi. There, the value of pi, well, it actually goes a lot longer, but by default, fprintf displays everything to 6 decimal places. But what if you only want to display pi to 2 decimal places? What would you do? How would you display pi to 2 decimal places?
So you put a point to.
Yep. Now it'll show it in 2 decimal places. Pi still has the same value. It goes on to infinity, but we only see 2 of them. So this is not changing the value, it's changing how it's displayed. Now we can also force it into scientific notation, which is always fun. I don't know that it's actually always fun, but there's pi in scientific notation, and we already know how to do decimal places. So, gentlemen. Does what you're doing have anything to do with MATLAB? Okay, thank you. All right. Moving on. So we've been through all those things. We've done those things. We've done that. We've done where you put things up. Oh, here's another one. What if you have a bunch of numbers and you want them to print in a column? So let's create a new little program. Everybody. We're going to have num1. And you don't have to put in the same values. 1, 2, 3, dot. And we're going to have num2 equals. So these numbers have different widths. And if we print them out normally, print F. We'll just print out the number. And I need to change this because that's really not as good an example in my thing as it should be. Okay, well, let's do it so that it actually is a better example. So I'm going to do this. This is a float. So if it's a float, I do percent dot. We'll just say we want to see 2 decimal places, right? So far, so good. And if I want to see num2, I would do percent f dot 2. And I would put num2 over there. Yeah, I need to rewrite that because that's a better way to do it. All right, so as we go through the class, I will discover, oh, I'm doing result vectors again. We're going to get to vectors in a minute and matrices, which is what MATLAB is really good at. There we go. Whoops. I need these on separate lines. So I put in an N here. There. I need a CLC because now I'm getting confused. Let's try that. There. So aren't those numbers beautiful? Would it look better if the decimal points were lined up? I think it would. So let's print them so that they can be lined up. So in the little formatting thing, this takes care of the part to the right. If you put a number in here, that takes care of the part to the left. So for instance, if I put in 4, which is more spaces than this has, and I put in a, get the right place here. And I did that wrong, didn't I? Percent F dot 2.
Yeah, F has to come after the point two.
Right, you're correct. Thank you. I had this one all backwards. Now I can put the 4 in here. There we go. So these are both formatting these numbers the same way. And I also want to go to the next line at the end of the program. All right, what did I do wrong there? Not supposed to do that. There. Apparently 10 is the magic number. I had to go more characters. Now they look beautiful, don't they? The decimal places are lined up. That's one way you can print out a bunch of numbers. The decimal places line up. It looks nicer. And my example in here is not as good as this example. Oh, I did do it. Yep, never mind. I did do it. I was reading it wrong. So what the things we've gone over allow us to determine how many decimal places we have. We substitute the variable in for the percent. The S or the F are the 2 most common ones we will use. We'll be primarily using floats and strings. We will also be using integers, but we're not to the point where we're going to be converting between one and another yet. We need a dash and a slash n to move to the next line. And if you put a number on this side of it, this tells us how many decimal points to the right. This tells us how many characters to the left to put in. So that allows us to format our numbers pretty nicely. I have one shaking of the head. I see no puzzled stares anywhere. So I think that's a good thing. All right. Let's stop.